If one of us wanted to start writing a fiction book, right? Like right now, right this second, we could do it. It wouldn't be good, right? But we have the tools available to us to do this thing, right? That's not true for games. There's something that feels wrong to me about that, right? I want anybody with a cool idea to just be able to start working on the thing.
I actually think that computer science is really creative and in a ways that people don't give it credit for.
Oh, absolutely.
Yeah, like it's problem solving and it's thinking big and then thinking small and breaking something down into small pieces. I actually think there's a lot of overlap with art. My intention was to be a graphic designer and go through fine art school. People are very surprised that I ended up here. I actually think it's not that different.
It really isn't. I mean, it is still a creative process. Like obviously the goals are somewhat different sometimes and the conventions, but yeah.
Yeah, so that's, I mean, a great intro for today's episode, which is about creativity and computers.
Yeah.
This month on the pod, we have Matthew Guzdial.
Matthew is an Amii Fellow. He's a Canada CIFAR AI chair, and he's at the University of Alberta, and he works in computational creativity.
I know what you're thinking. Computers? Creative? How could it be?
Matt works on a lot of tools to kind of collaborate humans and AI on creative works. And we wanted to talk a little bit about how that works. And not only what does that mean for the creative field he's working in, but also what could that mean for other areas of AI.
And he gave some great definitions of creativity, which I thought was really cool.
Absolutely.
Yeah. So here's Matthew Guzdial.
Welcome, Matthew. Thank you for joining us. We're really excited to talk to you today.
Happy to be here.
Yeah, nice to have you.
You work in computational creativity. And I know what those two individual words mean, but when you put them together, what would you say computational creativity is?
There's some debate, but I'll say what I think that means. And that basically means that we're going to take sort of human notions of creativity, often from the cognitive sciences. So like from, people who are like real psychologists like Alana, who've like really studied these things and understand how they work in humans. And we're going to try to represent those processes in a computational system, right? Okay. So creative processes in a computer, computational creativity.
Oh, wow. So why did you first get interested in that area?
So I've always been sort of interested in, the arts and creativity largely, right? So as a kid, I would make little games or make little animations. When I went to do my bachelor's, I actually thought I was going to go work at Pixar. But then, I was sort of got interested in this idea of like not just making art myself, but like let's helping other people make art. Right. And when you get into this question of helping other people make art, you get into all these questions about like, okay, what is creativity? How do we support somebody's creativity? And to be able to do that in a computational system, you have to have some sort of way of thinking about the creativity in a computational way, right?
Okay. Because I think when people think about like creative tools, the creativity is all on the one side and it's just tools, but this sounds like a bit more of like a integration, almost like an amalgamation.
Yeah, totally. There's a lot of words for this. I like amalgamation. Mixed initiative is a common one, right? So the idea is that it's not just the human who has initiative here, it's also the system that has initiative, right? And that by working together, you can like make cool stuff that you may not be able to otherwise.
And so one of the things you work on is video games. And based on what you just said, I wouldn't have guessed video games. So what is it about video games that makes it a good place for this?
Yeah. So I think video games are a great place for this. There's a German word that I'm not going to be able to pronounce here. It's like Gesamtwerk or something like that. But it basically means like an all-encompassing art form, right? So it's an art form that contains other kinds of art forms. It was actually coined for opera.
Oh.
Right? Because opera is like costuming, it has like architecture, it has obviously music and writing, et cetera, et cetera, et cetera. Yeah. And games are also that, right? So games are a medium that contains all other media. So that makes them really interesting for this because anything we get working in games, we can probably extend to other kinds of media. But games are also really interesting for other reasons, right? Like we're at the University of Alberta. Jonathan Schaefer famously was at the University of Alberta. He just recently retired. And, his argument, the argument of many other people interested in sort of automated game playing has been that games are a really nice simplification of reality, right? Because, we have real physics, right? If I were to drop this glass, it would shatter terribly, which I won't do, don't worry. Right? But like in a video game, I might drop something like this and it wouldn't shatter.
Right.
So it's a simplification, but it's a simplification that's a reasonable approximation of the real world. Right. And so things we can get working in a game, maybe we can then extend into real world systems as well.
You've talked a bit about kind of wanting to make things a little more accessible with these creative tools. And we've talked about it a bit before in the past. I think you had this great line where you had said you want to make it possible for somebody's grandma to make a game if they want to. I just would love to know, like, what's behind that goal? Why is that something that you want to see out there?
This was primarily inspired by, for many years, again, back in my undergrad, some number of years ago, I was running this like game development club. Every single term, we'd end up with a situation where people would come in who were like, oh, here's the game I've wanted to make for years, right? And they might have like binders or sketches or spreadsheets, right? And there was so much like love and passion there for making it. And these were students without technical ability, right? Who were coming to this club in the hopes they could get other people who could help them make their sort of, their masterpiece in their mind, right? And so my heart was always broken to have to tell these people, no, sorry, we're not going to let you pitch this because it's just not a good fit for this club, right? And if we think about it more broadly outside of my own personal experience, right? Like if one of us wanted to start writing a fiction book, right? Like right now, right this second, we could do it. It wouldn't be good, right? But like we have the tools available to us to do this thing, right? Similarly for making music, again, we wouldn't be good at it first, but we could just do it. We could jump into it. There's freely accessible ways of doing this. Yeah. That's not true for games, right? There's some tools to help support you, like Scratch, which a bunch of kids use for making games, right? Or things like this. But there's nothing really that lets you like do the thing that professionals are doing in as quick of a way, right? And as little of an effort. You need like years of technical ability to be able to get there. Okay. There's something that feels wrong to me about that, right? I want anybody with a cool idea to just be able to start working on the thing.
So like, where does vibe coding come in? So like, I think actually people could get some of the way to making a video game.
Yeah, sure. Great question. So vibe coding, right? This idea that we're going to just like sit down with a chatbot and it's going to like help me produce some stuff, right? That's going to be helpful if you want to make a game that like is a small HTML game that could like run in a browser, right? So you can easily use this to like make a Snake or a Flappy Bird clone or like any sort of simple game like that is pretty easy to throw together like this. If you're making these larger games are actually at a scale where it's like outside the context, right? The amount of information that a large language model, a chatbot can bring in, right?
What about like the retrieval algorithms that...
Sure. So you can definitely do things like this. There's ways of doing this. And there's even, intelligent tools to help out for like Unity and Unreal, which are two like big game dev engine things, right? But there's actually a lot of work there in terms of like translating between like the output of the LLM into like the system's actual language and then back to be able to like accomplish these tasks, right? So they're really limiting in terms of what they can actually accomplish. So if you're trying to make anything sort of more complicated than one of these like one screen sort of Atari complexity games, chatbots by themselves are not really going to get you there, unfortunately.
One of the things I've always found interesting about the video game industry and like the scene is even like an indie movie or something, if it's a successful indie movie, it's still not going to be like a blockbuster.
Sure.
But there's definitely been lots of cases of like a small studio or even one or two people making something that gets a lot of attention in the game making space.
Totally. Yeah. There's a ton of examples of that, right? Like we could go back over the last few years and some of the biggest games were made by, a small core team, maybe with some contractors or something like that on the side. Yeah, it's very viable.
So how do the things you make differ from what people would traditionally use to make video games?
A lot is what we were talking about earlier around this notion of like mixed initiative, right? So there's a bunch of tools out there just to like briefly talk. We talked about Unreal and Unity and stuff like that. There's also some tools for like specific things, right? Like if you want a lot of trees in your video game, there's a tool called Speed Tree. Wow, right?
Does what it says on the tin, I guess.
Yeah, it's amazing. But Speed Tree is basically the reason why in 3D games you don't just see the same 3 asset repeated a million times now. You get like small variations, and so it's like, wow, look at all these different trees. So there's tools like this, but they're very specific to like, okay, here's the one thing we're going to try to make.
Trees.
So we're trying to do either things where like we're bringing in this AI partner, right? Because again, we're sort of assuming maybe you're a novice who doesn't really know, and we can help try to like structure you a little bit. Or alternatively, we're trying to do something where it's like more general than just like, let's make a tree, right? Let's try to make everything, right? Let's try to support the entire game development process.
What's the AI part of that?
So let's start with the first one, because that's a super obvious one where the AI comes in, right? So the big example of this is I had this tool back in 5-6 years ago now called More AI Maker.
More AI Maker?
More AI Maker. And it was a joke because previously there was a game from Nintendo called Mario Maker.
Oh, okay. Yeah, that works better probably in text.
It does. So we swap around some letters and ta-da, it's more AI. So in that system, right, this was a tool for level design, because this was the original Mario Maker was. It was this level design tool, but there was no AI component to it. Mm. And basically the way it worked is you could basically pass the level back and forth between you and an AI. So you could start up making a level, and you'd hit a big button that said end turn. Okay. And then we'd have a little pop-up that says the AI is thinking. And then because it was computing what it should do, and then it would add in some other additional things on the screen. You just go back and forth like that, right? So the original version of the system actually just had a bunch of static models, so non-learning models. They'd been pre-trained. So we had like a Bayes net, we had a Markov chain. This was before deep neural networks like super took off, right? And everybody had to be using neural networks. And in that original iteration, we actually found that people didn't have a clear preference, or the statistical stats suggested that across the whole groups, there wasn't a clear preference. But when we dug into it, what was actually happening there is that individual designers had very strong preferences between the different agents we let them play with. And so what we basically figured out is, people are so different. We actually need to be adapting to them live. So what we did is we took a deep reinforcement learning, right? Shout out Rich Sutton, to use basically an imitation learning setup where we pre-trained it on all those existing interactions as if it was the other agent, right? Even though it was the Bayes net or the Markov chain or whatever. And then we let it continue to train while it was interacting with people. And this ended up being much more successful, right? Because we had this cool thing where now it was adapting to like your particular way of doing level design, right? Which I don't just mean like what components are you adding, but also like what kinds of additions are you interested in, right?
So maybe we take just like a little bit of a diversion here. Yeah, sure. When you're making a level, what kind of levels are you talking about? Mario, I guess.
Yeah, Mario in this case, right? So these are platformer levels. You have like ground chunks, you have like little floating platforms, you have little enemies going around, you have some pipes, or you have some like moving platforms, right? The tool also let you play the game, the levels as well, right? You just hit a button, you could play through it, etc.
Oh, fun. That's cool.
Yeah.
Okay.
That was the way that it was set up. And what we found when we did the second study with the Deep RL agent is that we actually had, at that point, like published game designers taking part. So they were using this tool, and we found that they could like make vastly different kinds of things, right? Previously, people were sort of like focused in on just sort of making a very standard looking Mario level, and that were very different after this. And we also found that the tool adapted to them differently in terms of like whatever they were interested in, right? So like, were they just sort of like having fun, right? And wanting to get sort of fun interactions with the tool where it would do sort of interesting things. By the way, I should say, because this is RL, if they kept something that was positive reward, if they removed something that's negative reward.
Okay.
Right? So that's how it could implicitly figure out, you're liking things like this in this kind of state. I'm going to do more things like that.
All right.
Right? Yeah. And so because of that, we were able to get cases where people were like, okay, I want it to be more like my student. You know how students are, but they just do exactly what you want them to do. They do like just repeat what you did, basically, right? So somebody would like fill in a bit of ground and like want it to like fill in more, right? To sort of continue their work. Right. Other people wanted something more surprising, more interesting, sort of fun and interesting little interactions, right? Somebody wanted something that was more like a collaborator, where it's like, okay, I'm going to fill in the ground, and then you're going to fill in the things that should be on the ground, right? And it could like actually adapt, or at least through self-reports, they said that they felt like it was adapting to them. And we could see from just the weights, okay, yeah, it sure is changing, right? In terms of actually seeming to adapt to their needs, which is cool.
Yeah.
I guess that's also like, sounds like an interesting part of it is, I mean, there might be a difference between what the model is actually learning and I guess the perception for the person who's using it.
Yeah.
So, I mean, how do you account for that?
So we had an explainable AI section to this. This was actually a really interesting part of this study. So there was this GradCam, which is this explainable AI thing. It basically lets you like visualize what the learned filters were. This is, maybe more technical than I should be getting, but basically for this deep reinforcement learner, it was using conv layers at the time, which are like for image processing. So it's like, imagine it scanning over the level and saying like, okay, I'm seeing these things, and because of that, I'm going to do this, right?
So it basically tells you like, where is it looking?
Exactly. And so that could allow us to get a sense of like, okay, it was because of these bits, that's what the parts it was really looking at when it made this decision.
Okay.
So as part of the protocol for the study, if they asked us, and we told them this ahead of time, right, when they like signed the consent form and stuff, if they asked us to say, hey, why did it do that? We were allowed to say like, okay, well, here you go. Here's what it's printing out, right? Here's the pieces it was looking at, and here's the action that it did, right?
Okay.
But despite that, people would come up with their own explanations, sometimes that were directly contradictory to the information they were just given.
Oh, wow.
Which was like objective truth about like, this is the thing it was looking at, right? They'd say something like, oh, it just likes enemies. You'd be like, no, it clearly, it sees here there was this empty pit of ground and that's why it filled in an enemy. It's not that it likes enemies. Like, no. I'm pretty sure it just likes enemies and that's why it keeps doing that. So yeah, that's an interesting thing as well. That's a fun challenge in terms of people's perception of AI.
In the past, I've talked to people and they've said that like any creativity that you experience when working with an AI is not from the AI, but rather it's from your perception of what the AI did. So where would you fall on that?
Yeah, it's a great point. So I think that part of the trick here is how do we even define creativity, right? So I always go back to Margaret Bowden. Margaret Bowden is a cognitive scientist. She published in a bunch of AI venues back in the 90s. She's fantastic. So she defines creativity in terms of there basically being three kinds of creativity, right? And this is about not what is the effect of that creativity. She has a separate definition for that, but it's about the process to achieve that creative outcome, right? Okay. So we can say that somebody could either explore through a possibility space. This would be like a search or like a planning-based sort of approach, right? They could combine two existing sort of possible things, right? This is a super common form of human creativity, right? Christina Gagné, who's at the University of Alberta, she studies a bunch of this for language, right? And you can also do what she called transformational creativity, where you'd basically take an existing concept and you would expand it to say now it includes these other things as well. But then in terms of how we judge creativity, which is the important thing, there were two cool things that Margaret Bowden brings up. One of them is P versus H creativity. So P creativity is personal creativity. Okay. That's saying you or me looking at a thing goes, that's creative, right? H creativity is historical creativity, which is a theoretical concept because we don't know all of history, right? Yeah. We can't have experienced that. But that says across of all of time, this would be considered creative, right? Okay. And then in terms of how do we measure that, she has a really nice way of saying it's novelty, right? Something that nobody's done before. It's value. So it's not just that it's like somebody just said something totally random that was new but not valuable. It has to be valuable. And then it has to be surprising so that it's distinct from the things that people have been doing so far, right? Something could be novel because it's one step off from what people are already doing. But for something to be considered creative, it often has to be surprising compared to the existing set of things that we can do. And so this is where P and H creativity get really interesting, right? Because I could say, oh, wow, that sure was creative. But Alana, who knows more than me, would look at it and she would go, that's not creative at all. I've seen 20 different people do that, right?
Because of history. Yeah.
So exactly.
Like the context that it's in as well.
Different people's perspective. Right. So now I can actually answer your question now that we have some terms defined, right? So when we're saying, oh, wow, that sure is creative what that large language model or whatever output, right? You know, we could look at that historically and say, well, maybe, but probably not. What's probably more likely is it's retrieving information from a massive amount of trained data, right? Now, it might be taking that and like doing some small transformation on it, or its template, you know, as a template, and then it's filled it in with new things or whatever, right? So we could say historically, maybe it's not all that creative, or maybe it is, unclear. But the person sitting in front of the computer can look at it and go, wow, that sure is creative, because I've never seen anything like that before.
And if creativity can come from putting two sort of disjoint things together, I mean, I feel like that is something that these nets can do. Even if you learned about the two things from its data separately, they could come together, and that could be historically creative.
For sure. I'm not someone who says that AI can't be creative.
You kind of would be in the wrong field, wouldn't you?
One might say. No, but even like if we think pre-neural networks, and this is stuff that's still happening, right? But we can think about like genetic algorithms, right? Which is this notion inspired by obviously evolution, Charles Darwin's concept of evolution. We're going to have a population of solutions, whether those be poems or games or, you know, chip designs for like computer chips or whatever. And we can do crossover where we can combine existing solutions to make a brand new solution. And then we can check the fitness, how valuable that thing is, right? Okay. So for years throughout the 1990s, 2000s, this is how a bunch of people did computational creativity. They would just hook it up to a search-based process doing these sorts of things and be like, wow, look what it could come up with, right? And I completely agree that those could be creative solutions, right? And yes, I completely agree with you, Alana. An LLM can approximate this sort of process pretty well, right? In many cases. So yeah, totally. And it can output creative solutions for sure.
Interesting. Okay. But does it matter that the intent, well, did the AI intend creativity, or was it just?
Yeah.
I mean, it is just a bunch of math. So
it's just a bunch of math for sure. So this comes then in terms of how do we define intent, right? Which is another really interesting problem, which I actually have a number of PhD students who are interested in right now, including Emily Helena, right, who is working with me right now. She's great. So intent, unfortunately, is like really poorly defined in literature right now. We don't have clear notions. Like I just did a whole like, here's my like vocabulary for creativity. Unfortunately, we lack that for intent, right? But what does happen in the computational creativity field a lot is that people say that unless a process, some sort of generative process, is also evaluating its output and is capable of evaluating in terms of these notions of value, right, which are domain-specific notions of value, then they refer to it as mere generation, right, which is basically a way of saying that there's no reflection over the generation process, right? And so this gets tricky in terms of how we specifically define these terms, right? But you could sort of make an argument because it's just text input and output. There's no real way to get a clear evaluation, maybe, right? If you really strongly wanted to make this sort of argument about like, well, it's not really creative. But I wouldn't make those arguments.
What is kind of the step to move forward in that? Is it like the definitions?
We're not quite that. So there's a lot of notions in terms of intent, right? In terms of it basically being like a goal, right? Which gets us into like goal-oriented decision-making, which is a long-standing field in terms of how do people make decisions given certain goals, right? But what's really interesting about intent is that intent in a creative process shifts over time. If you start and you're like looking at a blank canvas, right, you might start with some intent, but then as you're making the thing, you're like, oh, actually, that's kind of looking more like this. Let me pursue that direction, right? Yeah. And so part of the thing that's really interesting, we actually just had Max Kermensky in town for Upper Bound, who's a friend of mine. They're at Midjourney. They're a senior research scientist there. And they've been doing a ton of research in terms of like, how can we elicit people's intents, right? And then how can we make systems that are actually supporting that intent, right? That is not just trying to like say, well, I'm a big language model and I have certain biases because of the way that text has certain, biases. And because of that, I'm going to lead you down certain pathways. Right. They actually have some really cool research on how, like, if you just put somebody down with a large language model and give them a particular task, a particular goal, they're going to produce basically the same solution every time, right? Which is not super satisfying.
Or creative.
Exactly. Again, because we get notions of novelty and surprise, right? Yeah. But over on this side, if you just get them to instead use some existing like brainstorming tools, right? To sort of like prompt them, the human this time, right? To be like, oh, actually, think about something like this, or like, oh, what if you thought about it from this perspective, right? You can sort of do an intervention and, okay, now it spreads out again. Now we have more interesting, more varied solutions. Right. So this is all to say that, there's ways of supporting people's intents with these large language models. And there's notions of how we can get at studying their intent, but we just don't have very good definitions for it right now. Right.
And so I'm thinking of when I paint, you start with an idea in your head and then you break it down into smaller pieces. And this actually also makes me think of what we had been talking about with video game creation.
Totally.
I think you might mean this differently, but the intent as I paint changes a lot. And it's not because I don't have the same end goal necessarily in mind. It's because there are small steps along the way. And the intent changes and what I would need to be supported would change also. So do you mean intent in like this broad, like picture of a man sitting on a bench? That is my painting? Or do you mean like small? Or do you mean both maybe?
So this is the question, Alana, right? So when I'm sitting down with, Emily Helena, my PhD student, a lot of what we're talking about is like, okay, how could we define intent such that it would be actually useful to try to capture some of this distinction, right? Are we talking about local decisions making? Are we talking about global decision making, right? And then, Alana, you're talking about your creative process, but other people's creative process is wildly different.
Yeah, totally.
Right? Yeah. You can think about like a Pollock, like flicking paint on the plaster. They're not like thinking about like a man sitting on a bench, right? Like they're thinking about like, ooh, color and texture and the ways those are going to like completely different representation, right? So that's the trick.
And I guess like, I don't know if others have had this experience, but I've definitely had some creative projects I worked on that I don't know if I fully understood my intent until like I had already done it.
Exactly.
And it's only at the end of the process looking back that I realized like, oh, that was what I was trying to do. And it wasn't consciously.
That's interesting. So you couldn't have elicited it during the process.
Or at least not in like a just explicit way. It would have to be, I'm sure there were signs there. I didn't pick up on them.
Yeah, we've been talking about wanting to do like a longitudinal study, right? Where we'd basically like have people do some creative tasks, have them elicit their intent in some representation, TBD, but then having to check back with them, right? Asking them to reflect back and see like, okay, is this consistent, right? Because as good scientists, we would love something to have test, retest, validity, right? That's a nice thing for something to have. It's tough.
How do you deal with, because I mean, a lot of the things you could think of as intent or goals are very abstract. Like, I mean, like I want to make something that someone finds fun.
Totally.
How do you, like, I can't even describe that. How do you kind of build that into this computational creativity?
Yeah, that's a great question. So fun is its own bag of worms. I'm gonna put fun on the side.
As soon as I said fun, I could see you're just like, oh boy.
Yeah. Fun is its own thing. But more broadly, right? Thinking about like, how can we support people in a particular creative experience, right? I have a particular goal. I want the player to experience something that's like this particular goal, right? This is a real challenge, right? Particularly because not only is it the person then has to think about the designer, the designer has to think about, here's my goal for this game. I want people to feel like this. But then you have also all these different kinds of people.
Yeah.
Right? Who will come to that with very different, like the range of possible experiences that like a single game can support is much broader than like a designer's intent might be. I might say, okay, what my intent is, I want somebody to like feel scared here and then feel relaxed here and then feel tense here. Right. And then the person might come in and be like, oh, this is hilarious. I'm just like, I'm laughing the whole way through. And that's wildly different. Right. So there's a lot of questions in terms of how we do this. I'm not going to have the time to break this down entirely, but one of the simple things that we did for even just this Mario Maker tool, because then I don't have to re-explain anything, I don't have to talk about a new tool, is we ended up adding in automated level testing system into the tool, right? So basically what would happen is you would put your little level together and you would say like, okay, here's my start point and here's my end point. And then you hit play, and then rather than you playing through it, though you could also do that, we would send a horde of Marios through. So you would see literally like, hundreds of Marios moving through your levels simultaneously. This is a process called survival analysis, which is unsurprisingly based on like, ecological survival analysis, but much simpler, much safer.
Yeah, like the natural hordes of Mario.
They roam through the lands. Yeah. Yes, exactly. But with this, right, we could get a sense of here's the spread of possible experiences, right? Because we're literally showing them to you. But then we can also show you sort of like after action reports and say like, okay, this many made it through. This many died in these locations, right? And this gives you a sense of, not does it match my exact experience, but what are the possible experiences supported by the thing I just made, right? So that's one of the ways we try to do this, of like giving you the kinds of feedbacks you'd need to make that decision.
And this sort of is starting to veer towards explainable AI. Is that,
Totally.
Yeah. So where does that come in with your work?
Trying to figure out what information to give people is really hard, right? So this is getting into like design research or design as research or research as design. There's a lot of different phrases for this, right? But basically when you're coming down to like, I'm going to present some information to a user, thinking about how is this information actually helpful, right? Or is this giving them the kind of information they would need, they feel they would need to be able to make their decisions?
Right.
So I can give you a negative example.
Okay.
So Dr. Nathan Sturtevant, who's also a candidate CIFAR AI chair, also Amii fellow, et cetera. He's great. He and I built this tool that we called Nhinga. It's based on this like puzzle game called Snakebird. And basically it's like snake, classic snake, you're eating fruit, right? You get longer with time, but it's also a puzzle game. You have to eat all the fruit and then you have to escape the level, right?
Okay.
So Nathan has this great way of doing generation for these levels. It's called exhaustive PCG. The basically idea is you generate everything. That's the high level idea. Just generate it all, and then we're going to select from there, right? Because then we have the full space. We know objectively these are all the possible things, and we know objectively we've got you the best one, right? for some measure of best. This is where things get tricky.
Yeah.
So we made a tool, and the hypothesis was that the difficulty of the puzzle was around its solution length. So how many moves would you have to make from the beginning to the end? That means how hard it is. What you could basically have was, again, a level design tool. You could see your current level. And on screen all the time, we would say, if you move this block, so if you delete this block or add this block, it will change the solution length by this amount.
So they've got an idea of like every individual change, how that's changing the difficulty of the level.
But not even what changes, how is it changing? What changes could you make?
Oh, okay.
Right? Because they're just like hovering over the screen with their tool, and the screen is live updating to say, if you make this change, this is the kind of impact it will have in terms of the solution length. People hated this.
I was going to say, that sounds like a nightmare if you're trying to like do it, because you get like choice paralysis. It feels like a recipe for it.
The other way around, actually. People felt like it was guiding them way too much.
Oh.
Right? So this is this notion of explainability, right? We've done this sort of big generative process. We have all this information. We're trying to find some way to squish it down for you, right? Which is the high level notion of explainability, right? And in this case, they hated this because they felt like, oh, all they want to do is make the number get bigger.
Yeah, okay.
So I'm just going to pick the biggest number on screen every time.
Right.
And it was really hard for them not to do that. And they felt like it was way constraining their creativity, right? The sort of possible options they had really constrained down. It's the similar notion to the LLM thing we talked about before without prompting, right? Yeah. Comparison, we just had people play around with a tool. We didn't show them that information at all. All we did was, again, give them this solver. So it wasn't a horde of Marios this time. It was a single one of these snake birds, right? And it would just find the shortest solution. And people loved that.
Oh, I see.
Okay.
Right? And so that's really interesting, right? Because they're sort of the same thing.
Right.
The difference is how you're presenting the information and when you're presenting the information.
Yeah.
Is it constant? Is it only when they ask? Right? So all these questions end up coming out in terms of how and when do you give them the information they need.
Yeah. It also allows them to ask the question, like, why is it harder? So if the number goes up, but it's not clear why. But then you see the snake play.
Well, in this case, you could have still hit the solve button, even in the version with all the numbers, and people still liked it that was there, but they really hated the numbers, so didn't help.
And I'm going to assume that balance of how much information when, like, that's not a global thing. That's going to be very individual, I would imagine.
It totally is. It's great insight. So people who, we didn't have enough to like fully support this, but it seemed like the people who had more puzzle design experience hated the numbers more.
Right.
So people with less experience felt like, oh, okay, this is a guide. This is helping me. I don't really know what I'm doing, right?
Yeah.
People who've had all this experience were like, I have an intent in my head that I'm trying to achieve. And I feel like I'm fighting the system to achieve this. Right. And this is actually really similar to the language you see around people using large language models or not, right? Some people are like, wow, this thing's amazing. It's changed my life. And some people are like, I'm fighting with this thing constantly to like get it to do anything that I want it to do, right? So it's, insights.
Interesting. Yeah.
We've also talked about other concepts like transfer learning.
Totally.
How does that relate to exactly what you're doing and then kind of outside of this particular application?
So transfer learning broadly, just to say it in case people are not familiar, right? The high level idea, we have some knowledge over here. We want to take it and put it over here, right? Often the case is that we have a lot of data in one domain, right? And we want to try to solve this other domain where we have much less data. Simple example is like we have all these images of, cats and dogs, but we don't have images of this rare mammal that we only have like 10 images of. Wouldn't it be nice to be able to transfer that knowledge over to get better at recognizing this animal, et cetera, right? So I mentioned before notions of like combinational creativity as like a creative, way of thinking about the creative process of humans. So during my PhD, working with games, was working on trying to do game generation. So we had these machine learned models of games. We had 3 of them. And then I was like, well, can we smush these together? Thinking about combinational creativity to be able to represent a new unseen game. Yes, of course. The answer is yes, you can do that. You just have to be clever about your representation. But the way we ended up doing this was we basically represented as like tensors. And so the combinations we were doing were like over tensors. And that immediately got us thinking about, hey, could we do this over neural networks, which are just a bunch of tensors? And the answer turned out to be yes, right? So we could do really well. We could do like a one example of seeing a fox having seen like cats and dogs. Suddenly we can have a really accurate fox detector, right? By just doing this sort of same process of recombining the weights for like the cats and dogs. We can even do this for generations. We can like generate you images of foxes, having never seen a fox before, right? And what this ended up meaning was, oh, this is really useful in low data cases. So cases where we have really, really low data for our target domain, doing this sort of approximation by like combination ended up being really powerful in terms of approximating this target domain. And so because of that, we started looking for use cases, and we actually found like, oh, hey, we worked with Service Credit Union here in Edmonton because they had this financial program where they only had run a few people through it, but they wanted to be able to say like, if we took some new person, we put them through this program, how do we think they'd do? Right. We found it was really helpful there. Working with Simon Urschel on organ transplants in kids, unsurprisingly, not a lot of data there, right? So again, and if you have enough data, this stops being helpful, right? Like if we get up to the point where we have hundreds of data points, you just do something more traditional machine learning wise, no problem. But it turns out this notion of doing combination, which maybe is understandable because it's such a common way we humans do it, right? Mm-hmm. If you have data that's sort of human interpretable, you can often do a really good job of approximating the unseen information by just doing this combination process. So that's been really exciting.
Yeah, and I mean, like, that sounds incredibly useful because, I mean, a lot of the things we are concerned about and want to know more about are those really rare things that happen.
Totally.
Also, I like how you kind of took what you learned about transfer data and then transferred that over. So it's kind of like meta stacking it on top of each other.
Yeah, exactly. I mean, I mentioned earlier, right? Like games is a nice, simplification of reality, right? Being able to see, hey, okay, this is a thing that works pretty well in games. Can it work elsewhere, right? I've done similar things for like computer chip design, right? Which we can think about as being kind of like this sort of level design problem. It's about space and structures and how things connect, right? So the idea of developing sort of design technologies in games where it's nice and safe and nobody gets hurt, and then we can like actually use them and we know they work in these other domains, that I think is a pretty cool idea.
So I'm sure you've probably heard the critique that some people who work in creative industries are not happy about AI. So totally. Do you have thoughts or?
Yeah. I mean, I completely understand where people who are not happy with sort of big, tech industry generative AI stuff, right? A bunch of people, if you talk to them, right, and I do talk to them, right, are concerned around like, hey, this thing was like trained on my data. Nobody asked me. There was no consent there. So there's a feeling of like, it feels like something was taken from me, right? And there's also people who very understandably are worried about their jobs, right? Because even if it's not the case that they could be replaced, somebody's trying to convince their boss they could be replaced, right? And that's a really scary thing. So like, of course, there's also ecological and economical things, et cetera. Lots of concerns there. So I actually have a currently ongoing project with Hyper Hippo Game Studios, which is a game studio out of Vancouver here in Canada. One of the very first things we did was we sat down with their entire art team and we said, hey, we're not evil. We didn't come here to try to take your jobs. In fact, we have no profit motive, right? We're academics, right? We're just trying to like figure out how best we can support you. So the first thing we had them do was go through and outline their whole process and say, here's the bits we want AI to touch. Here's the bits we never want AI to touch. Here's the bits we could imagine AI touching potentially, right? And then from there we could go, oh, okay, so these bits aren't really research projects, but this one definitely is. And there's clear overlap in terms of your needs and our interests in terms of studying, AI and creativity, right? And so I think this kind of process is the thing that's really missing in the field right now, right?
So you're finding that the problems where it's both an interesting research problem, but also something they're okay with AI touching.
Exactly. Yeah. Exactly. And I think this kind of communication is the thing that's really missing in terms of like big tech industry, right? Like they're just doing things like rolling out in, Photoshop, here's a new AI thing. Like you have no choice whether it's there at all, but suddenly it is. And like somebody's going to be expecting you to use it because it's there, right? Nobody talked to them, right? There's this notion of like human-centered design, right? Where we're trying to talk to humans and say, what do you actually want? Right. What would actually support you?
And not after the fact. Like at the beginning.
It's not asking after the fact.
No. Art is often about really exposing yourself and really being vulnerable, right? Like this is my truest truth and I'm putting it out there, right? And the idea that like that's just going to be compressed down to like ones and zeros, right? In a big old matrix and used to train a massive model, like that feels like you're just like burning my dreams, right? Like that sucks. And there's much better ways to do it.
When you're talking about the studio, you're working with the artists and they talk about the kind of things that they prefer AI to do.
Sure.
Can you give an idea of what type of work that was?
Sure. So it's the stuff where it's like, it is like the busy work, right? So we came in with a particular notion. My student Dagmar Loss, I should shout out. They're great. So they came in with a particular notion of, oh, we want to build this sort of tool. And it was something closer to the sort of co-creative tools that we've made in the past, right? Where it's sort of like part of the process and integrated. And they were like, we don't actually want that, right? Because we like doing this whole process ourselves, and they're experts, so they don't need the sort of like hand holding that we found like early level designers needed, right? But instead, what they were saying was like, oh, as part of our job, we have to do all these like converting to different formats sort of things, right? And I'm not going to get specific in terms of what formats are, like what the things that are happening there, but it's basically the same thing over and over. And that's the kind of thing that a machine learning system can do really well, because there's all these patterns of like you having to do the same task again and again and again. It's boring work. They don't want to do it. And they've already done the creative bit. All they're doing is like moving it between different sort of representations at that point.
Right.
So maybe we'll end with the big question, which is, where do you see the field going in the next 5 to 10 years? What makes you excited?
Where's the world in the next 5 years?
I know.
No, it's the whole thing. But a real thing that seems to be happening right now across creative industries is the sort of like shrinking down of the sizes of these teams, right? Yeah. So if you think about like film, for example, right? Like Sinners is this film that just came out fairly recently, and it was like privately made. You know, is this one guy, it was not a massive studio behind this, right? So it was made at a smaller budget than normal, using all these sort of interesting techniques, and it's made a wild amount of money, right? So this is happening in movies. You already mentioned it's happening in games, right? For a long time, this has been true in writing, right? One person writes a book, it turns into a bestseller, right? It happens in music all the time. So it does feel like we're moving away from really, really, really big studios making creative works and towards smaller groups making creative works. And if that's the sort of world that we're in, I think we actually have a really cool opportunity for tools to support those kinds of people, right? Because these are going to be people who, because they're in smaller teams, are not going to have the resources of the massive teams to do the massive things. So you have all these cool opportunities to do weird stuff, right? To be able to support them and like make things in, fill the gaps, et cetera, et cetera. So that's, I think, where the future is sort of heading with these sort of systems, right? Of like supporting small teams to be able to do sort of big visions.
Great.
I love that. Yeah. Sounds like it could be really impactful.
I hope so.
Well, thanks for joining us.
Yeah, thanks. It's been a lot of fun.
I'm going to be honest now. I think anytime I do like a creative thing, I'm going to be looking at them like, well, okay, so it's P creative. Is it H creative?
That was great. I really love talking to Matthew. I'm really happy that he could come in and tell us about his work.
Yeah. And I mean, he just thinks about creativity in a different way. And now I'm going to be thinking about it another way.
Yeah. I will probably also do the same.
Yeah. A whole bunch of new anxieties to unlock.
Yes. Thanks, Matthew.
But actually, thank you, Matthew. Yes. It was a great interview, and we learned a lot. And if you want to help us in this creative endeavor, best way to do that is by subscribing. You could subscribe to the podcast on Apple Podcasts or Spotify. And if you're already subscribed, please leave a rating. It does really help us get the episodes out there.
Yeah, and share with your friends and family if you think they'll like it too. This is one I think could really appeal to a lot of different people.
Absolutely.
You can also like and subscribe on YouTube. That would be very creative if you did it both places.
And also leave a comment, because we love to hear what people think about the episodes.
Yeah, tell us what you think is creative, or whether you think AI can be creative.
Yeah, that's a great question.
Until next month, I'm Alana Fish.
I'm Scott Lilwall.
And this has been Approximately Correct.